Okay, let me try to kick it off. Firstly, I congratulate us all on the 2 amazing days ahead, because I don't know how about you, but I love this conference dearly. And I think that you will either love it too, or you love it already. For me, it is also so dear because it's search engineers oriented, and I am a little bit of a search enthusiast myself. I am a senior developer relations of a vector search engine, open source one, which is written in Rust. This year we even sponsor, can I point it? This is Quadrant. So if you will be able to stop by our booth, we'll be very happy. And today this talk is also a little bit of search enthusiast tailored. So it's for the ones that build with search, build search applications, or work as search engineers. However, if you're none of them, I'm also super happy to see your faces, just the curious ones. And after, please connect with me, please ask any questions. I am in general a big yapper, and you will notice it through the presentation. So I will wait 1 millisecond when all of these lovelies will sit down, and then we will kick in. Today's talk is about relevance feedback inside the search engine. Guess what? It's inside Quadrant, a little bit, like surprise, surprise. But mainly, what is it about? It's about yet another instrument to improve the relevance of search results in your applications. Probably you didn't hear about it, but it's very intuitive. So, obvious problem setting. You are building something with search. You're building, like you picked up some library, some search engine, you're trying to put the search inside of your application. And then often the problem out of the box is that your user comes at some point and the results that provides your search application are not fully relevant. And there can be different reasons to that. It might be that the search query wasn't perfectly formulated, which happens a lot of times in search because you don't know what you're searching for. Or the search query is good enough, but in your storage you don't have a perfect match for that query. Or even the search algorithm out of the box itself is not that perfectly calibrated to match your queries to your documents. However, the grand problem out there is you're a search practitioner and you need to somehow fix it. So you start thinking how to fix this search relevance. And there are many instruments out there that you can use, like reranking, cross-encoders, blah, 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 hybrid search. But one of them is pretty intuitive, and you will hear on the next slide that whatever is intuitive exists in academia for 60 years and continues to develop. And these are feedback loops in search. They're very well known to any search user. You do it yourself when you search for something like, I don't know, an Amazon or Zalando, you query, you don't like the results. You kind of look at what you got on your query, you do some inner self-evaluation, some feedback, how relevant is it to my query, maybe more, maybe less, and then you somehow adapt your search and go to the next iteration and cycle until you're fully satisfied. Also, deep research kind of works like this. So you get the results, you look at them, your agent looks at them. Is it everything that we want to see? No, okay, I gain some knowledge, I go on another round. This intuitive mechanism has actually a pretty official name in informational retrieval research. It's called relevance feedback loops. And it exists in many forms and layers for actually as long as 60 years, starting with Rocchio and Rocchio relevance feedback loops. This is a mechanism for the retrieval system to iteratively refine results in the direction of relevance. And here the question is like, okay, feedback loops, but who provides feedback? So the first guess would be that the search user, so somebody sits there and writes, yeah, that works to my query, that doesn't. The thing is that if your search user is a human, you can't expect them to do anything at scale because people are lazy. TLDR, like Google at some point even had on their search page thumbs up and downs. They had to remove it because people never were pressing them even. So there is another option how to use search and feedback loops. You can move them inside the search application. So everything will loop with the feedback until you will get a full set of relevant results and you can push them to the user. In that case, the feedback is better to be provided by a model, like an LLM, an agent, a smart reranker, anything that knows in your search application what is truly relevant to your query. And you would say, okay, I have the feedback, I have the idea of feedback loops, they're inside my search application, so how can I adopt the search pipeline based on like all of this feedback that I get in the loops? Everybody will think that you can adopt a query, because this is intuitive. That's what, for example, the coding agents doing now. They query your code base, or they do the deep research, they look at the results, and then they try to reformulate the query, extend it with synonyms, or do something else. There are like actually a lot of methods. The thing is, there are more components in search than just a query. There is also, okay, you can do different classifications, but from my perspective, search can be kind of divided in 3 components, which is query, storage, documents, and the function that kind of matches queries to the documents based on some relevance in some index. And you can adopt the query, obviously. You can't adopt documents, because why would you adopt documents per query, per use case? But one thing that people think less about in the relevance feedback loops is the search algorithm. You could also try to adopt the search itself. But here comes the problem. Search libraries, search engines are usually like black boxes. So you usually build around them. They don't allow you to access the index anyhow. So in the research literature, which I at some point went to look in and classified a little bit, also the ways of rewriting queries, so you can check it out. In the research literature, what people do with search engines when they want to adopt the scoring function, the search function, they just try to use this black box to get as many results out as possible of the search engine with a basic algorithm, then take the feedback and do some smart reranking based on feedback. And then the top results are provided to the user of the system. If they could, they would rerank the whole storage of the documents, and that would put up the more relevant results, but they can't, because they are dealing with black boxes here. So we don't have anything which would work on the whole collection of documents. But in our search engine, we are owning the index, and we are owning everything that comes in it, all the parts. So we decided to ship the API, which allows you to actually propagate the feedback right into the search, into the vector index itself, because we're a vector search engine. What does it mean? So what at least vector index native means for quadrant. How vector search works, I'm pretty sure everybody knows that, but in general, the idea is that the query comes, it gets turned into the vector, and then in the vector index, it gets scored against the all vectors documents out there. There are several different types of vector indexes that exist. We have HNSW, which is here on the right. It's a data structure that allows vector search at scale. And basically how it works in its vanilla setting is that the query vector comes, and then you traverse this HNSW graph based on the Kassayan similarity, choosing the next neighbor on your path based on how this neighbor is similar to the query. So you find basically something which is more similar out of all possible options for the next hop. And then you do it greedily, you do it greedily until you arrive to the best possible similar match, and you present it in your search results. So the idea was to move this feedback propagation right into the HNSW traversal. So when you get the feedback, instead of trying to build around, you could actually put this feedback right into HNSW traversal. So you change the function, which for every hop chooses the next node on your path. Before, it was just a Kassayan similarity. Now, it will be a combination of Kassayan similarity and the feedback on your search results of the previous loop. And that means that maybe this feedback will adapt the path in this HNSW graph. The details are in this article, and I'm really happy to share it after. But basically, the idea is that we're changing the function, and now we have, instead of just similar, like simple cosine similarity in the index, we have a combination of the original similarity and the feedback. It's combined with the 3 parameters, which decide how much we're trusting the basical retrieval and how much we're trusting the feedback. And then you obtain these parameters by a very simple training. For machine learning gals out there, you know that training 3 parameters takes like 150 examples or so. The training objective is that our goal is basically to distill the feedback smart model knowledge right into your search. So your search, your dense search, will rank as well as your feedback model would, but you never could afford to use it on the whole collection of documents. What do I mean by feedback model? What can you use? Basically everything. Your custom learn to rank, your cross-encoder agent, whatever is able to score your query against your search results in the interaction and provide fine-grained score. And that sums up into a relevance feedback query API, which could be used, and you could check how it's done because it's open source, so every cards are open. How it looks, so imagine that now when you're querying a search engine, besides providing the target query, you also provide your feedback examples with their relevance scores, and you provide the parameters of the formula that I showed before that you train once per your search case, which means once per feedback model, per your collection of data, and per your retriever, not each time per query. But when I say train, it doesn't mean that you have to train it to use it, because obviously nobody needs to have a machine learning degree to use a search engine. So there is a framework which provides you with weights. And also, if somebody is actually interested to try it out, there are several ways. So the first one, for people who still like to do tutorials themselves, there is a tutorial. But there is another thing that I am kind of proud of, is now we're trying to build search engineer skills for agents using with our vector search engine. And one of the search engineering skills that I build is a relevance feedback skill, which basically explains agent what is the best mode of using this feature. And I tried it end-to-end on my project with Claude. I was like, hey, Claude, don't see enough relevant results, what to do? Managed to do it end-to-end with training and everything and run the query correctly. And also for benchmark lovers, because I personally respect that benchmarks are there, there is also a repository which obviously checks this feature on Bayer, because on else what can we check whatever is happening in search. Basically, there are 2 modes of using it. I would say that, I got the question, how much is it more expensive to use? It's pretty much the same as the dense search itself, because the formula is very simple. But what costs is getting the feedback from the feedback model, and that's why you get kind of 2 modes of using this relevance feedback vector index traversal. First one, if you want a cheaper alternative to reranking, where you just get a couple of feedbacks, and then you distill your feedback knowledge into search, and it works as like a reranker on a bigger scale. And another mode where you combine it together. So it's kind of complementary mode, and it also helps to surface more relevant results according to my benchmarks on Bayer at least. To sum up all of this, this is a first, to my knowledge, vector index native relevance feedback API that I would love if you could try it. And it was possible because we own our index, so we could try to play with it and implement it. I think that matters a lot for the search community, because I don't like the idea that the search engines are black boxes that you have to build around. Search engines are here just to serve you a useful tooling and adapt to your needs and adapt to your users, be they humans or agents. And then they're going to be useful and they're going to be used. And that's what we're going to discuss today, by the way, at the panel. Today is going to be a panel. AI is here. Is it a time to throw away our search engine? So I'm hoping to see you all there at 5:20 at Kesselhaus. Also, I am happy to see you at my LinkedIn. And we have our own Vector Space meetup this Thursday. So if anybody is staying, please pass by. We're going to have also a very interesting panel with AI companies like NA10, DeepSet, Cogni, and such. Thank you very much for bearing with me, and I'm super happy to see you all today.
Okay, thank you, Jenny, for this talk. So I guess there will be plenty of questions, starting with Charlie.
Thanks, Jenny, that's great.
Hi, Charlie.
So relevance feedback, if the user is marking results that are either irrelevant or relevant, or somehow there's a proxy for that in terms of what they're telling you. But if you're not showing them any of those unreachable results, by definition at the beginning, they're not giving you any feedback on those unreachable results. Is this a flaw of this model?
I think it's to some extent the same problem that we have in deep research, like in the sense, yeah, there's not enough human in the loop, maybe, but we are doing it if we at scale trust the model enough, and we believe that it has the same interpretation of relevance as our users in general. I would say that this method might not work in a very human-oriented domains, like, say, e-commerce, where you would like to keep the human in the loop. But for some domains where it's more important to gather more results that are very relevant, like, say, deep research in medical or scientific literature, that makes more sense because the humans don't have enough energy to stay in the loop.
Okay, thank you. Another question?
Yeah, thanks for the talk. Building up on the question from Charlie, actually, maybe one part of the loop could be to evaluate different set of queries and then store the feedback somewhere, and then use the feedback at retrieval time. Could be this the opportunity to showcase what was not discovered during the first search? So
that sounds actually interesting. It's like iterative retrieval fixing. I think that could be of use for sure, because then I'm a big fan of the idea that you can do a little bit of reinforcement learning training on the agentic search loops. So maybe that could be a separate feature to use in the future. I like it.
But you're not currently storing the
No,
feedback?
it's more just gaining more and more relevant results until the model says stop, basically. But I mean, it's more like a tooling, but the way of how you use this API, it's still more on the search crowd in the sense that they can store it if they want it, because as a search engine, we more like provide a component which allows to do it in the loop. So I can see it how you can integrate the storing too.
Cool, thanks.
Okay, so we have time for one or two more questions. Yes?
Thanks for the talk. Also building on the same question, so not just about the products or results that were not shown, how about position bias? Does the feedback also take that into account?
I think it might depend on the model. I believe that some feedback models are trained also to take this bias into account, but this is depending on your choice. In general, I also think that depends on the search application if they would decide to put in the feedback bias, position bias. But I can imagine that like there are ranking models which also take that into account, and then it could help. But still, like we're using for the feedback top results, so to some extent you're still obviously biased because you can't afford to get and rank for the feedback a big amount of results for the sake of latency and cost. It's also funny that you're all building up on the question and you said there, did you plan it? Are you going to ask something?
Yes, last chance if you want. We have time for one last question, maybe? Yes.
Thank you for the presentation. The feedback loop heavily relies on the topology of the graph, especially in the top of the layers in the graph. Do you think that at a given moment you should rebuild the index in order to take into account the feedbacks and limit the biases in it?
Maybe that's an interesting point of view of rebuilding. Well, index is getting rebuilt to some extent anyway with the addition of new data. Now we're just changing the path of traversal in it. The thing is, rebuilding index is very costly, right? So we're trying to do with like this feedback into index suggestion the means that are making sense in production, and HNSW is a precise structure, but kind of heavy, so we're doing a lot of dancing around to make it effective at scale, so rebuilding it for the sake of maybe gaining a couple of accuracy percents here might be not feasible. But I will try and to do comparison. Like, my goal is, to be honest, to present this feature and see what opinions people have, and maybe then start changing it. Like, I don't think that the formula which is used is set in stone. I think just that the idea that people need to affect the internals of search engines appeals to me.
Thank you.
Okay. Thank you, Evgeniya. So I'm sure
Thank you very much.
We will be able to meet you at the booth.
Absolutely. Everybody come to the booth. I'm not coming home with that merch. So everybody takes one thing.
Okay, thank you again. I think we can...